yeah, let me. Can you share our meeting minutes and remind ourselves and we
Meeting
take.
summary?
Yeah, meeting summary.
Yep, I'm going to do that. Okay.
Okay, good. Yep. All right, let's let me hear what you as a team how you address all these questions and discussions.
Professor, I think we mostly address in the slide in the presentation. So
So in
can
the
we
slide
present?
you
Can we
yeah,
present
okay.
first the slide and then come
Yeah.
back to the meeting first later?
Sure. Yes, sure. You can do that. Yeah, go ahead with the.
Wasim, can you go
Let
to
me
the?
open that up. Sorry to open these documents. Okay. Okay, let's start off with the presentation. I think that'll provide some clarification. Then in the end, we can also talk about the meeting summary.
Okay.
Let me just open up a document to take notes as well, because I'm the note taker. Okay, so to start off, we were asked to redo the diagrams. So this is our overall view of the home automation controller. So we have Raspberry Pi in the center, which was one of the bigger components that you kept mentioning that we were missing. So around that, we have TensorFlow that we're trying to incorporate for human presence detection to incorporate the level of AI that you wanted. And like that will be sending images or taking that information to a database. From there, going to other ways, the Raspberry Pi is connected to Wi-Fi, which can send protocols through MQTT, and we explain MQTT later on. So it's able to be connected through Wi-Fi that is connected to all these other systems that all are able to send commands back and forth to each other. So through this Wi-Fi connection or through a Bluetooth connection, we would be able to send commands to our Home Assistant server, to our PCB controller that would be connected to relays that would perform some type of action. And then we would be able to even see these notifications or these changes on our mobile device that would have some type of user interface where we can allow notifications or we can allow changes to be sent either from the phone to these devices or from these devices to the phone.
So the question, so all this Wi-Fi that the one this Wi-Fi here, the block, how do I, let me see, how do I move the cursor over your presentation? How do I do that?
You have to access the remote control, I think, something like that.
Is that?
Do you see my, no, I think if you
have to
allow.
I think you can press remote control.
Yeah, to go to the option, request remote control.
Where, let me see. How do I do that?
So in the Zoom
option,
controls, like where you can mute and stop video, there's the option
Actually,
remote
go
control.
on the top of the screen. It says view options. From there, you can do that.
Yeah, look, that's request remote control, right?
Yes, exactly.
Right. Okay.
Yes.
And then request, and then.
Okay, approve. Oh, I have to update my settings, so I have to restart Zoom to do that. Okay, so I can rejoin the call in 1 minute.
Okay.
Okay, Professor?
Yeah, so, okay. So you have to
let me
log
rejoin.
out and.
Yeah.
I think, yeah, you need to give permission. That's how it works.
From where?
Okay, let me share my screen. Okay, and then you can request control again.
Okay.
You should have access.
Okay. So do you see my cursor?
Yes. Can you try to
Okay.
move it? Okay.
Yes.
No, this is my cursor.
What about this?
Where is your cursor? I don't. We don't see
Uh,
it.
Can
Oh,
you
you're
see?
moving my mouse. You can move my mouse. That's what's going on. Yeah.
Yeah.
Oh, I see.
Yeah. So you're moving my mouse. Okay.
Okay. So here the Raspberry Pi, right?
Yes.
Raspberry Pi. This Wi-Fi is actually the one Wi-Fi. One Wi-Fi attached to the Raspberry Pi, right? The built-in Wi-Fi.
It has
Correct?
built-in Wi-Fi. Yeah.
Right.
That's
Yes.
yeah.
Right.
Yeah. So
Yes.
this let's see. So I think what I was saying is that this Raspberry Pi here, and then inside, right? Let me join with my the touchpad, right? Touch, because it's hard to draw here. So yeah, let me
Or maybe you can
log off.
take a snapshot and then you can edit on your side, sharing your screen. You
No,
can do that
I
too.
will. Let me just log out, right?
Okay.
Okay.
Or I don't know whether I can come in both ways. Just a second.
You can log in both devices.
Yes.
Is it right?
Yeah.
Oh,
Yeah, but
I
then you
haven't
have
tried it.
to.
But,
You
So
should
you
send
have to
yourself a
request
link.
control from the
Yeah.
other device then, and not this device.
okay, so let me see. Just a second. Let me see if I can do this here. Okay, so let me get out of here, right? No, I think, or just let me mute this. Yeah, I mute this. Wow, why this one?
You should come mute your one of your mic. Yeah.
I think you can mute the mobile device. Maybe that's better.
Yeah.
Yeah, that's much better.
So how do I
Oh no,
submit?
it's still bad. Professor, you want to draw on this image? Your voice is muted. Oh, we can't hear you.
Can you just can you all mute? Yeah, good. That's no good. Let me. Yeah. So can you stop sharing? Good. All right. I think it works.
I think, Professor, you should use one of the speaker output. I think that's what there will be no
Okay,
echo.
so okay,
You should
let us
turn
do
off.
this.
Yeah.
Let me get out of this. Let us all get in again. And then I will use my notebook. Okay?
Leave the meeting?
Yeah, leave the meeting, everybody, and then join again. Right?
Okay.
Yeah. Thank you. Yeah. So yeah, let me share my screen.
Okay.
Yeah. And so what I was saying is this. For example, like this is a pie here. Okay, so maybe here there's a Bluetooth and there's a Wi-Fi, right? So, you know, CPU or whatever. And so here, Bluetooth, through the Wi-Fi, you connect, you know, so I think it's some Wi-Fi to wireless signals and go here and using Wi-Fi, either this way or something like oval, right? So maybe even this will work. And your, I guess, I don't know, the ECB here, for example, and here something, and because I don't recall. So can you just quickly show again your
The slide.
presentation? Yeah, just a second. Let me stop, because let me remember some, and then so that I can draw here better. Okay, let me stop, and why don't you just show me once again? Yeah, so here
We have the Raspberry Pi, the server, and the PCB controller. Is that what
okay,
you're looking for?
so yeah, here there's a camera.
Yes, camera. Says.
Where's the camera?
Yes.
And then it's a what is this? A home assistant server? What is a server for? So basically, I think what I was trying to draw is the Raspberry Pi here. Oh, this thing. Okay, so Raspberry Pi in the middle, right?
Mm-hmm.
And so inside of Raspberry Pi, there's a Wi-Fi.
Yeah, it already has Wi-Fi. Yes.
Yeah, I know. So there's no 3 Wi-Fi. You have only 1 Wi-Fi.
No, I was just trying to show that
Yeah, so
the
this is not a
connectivity.
good
Yeah.
diagram. That's what I'm saying. It's not good diagram.
No, we can adjust that in the future. Okay.
So several times is already, I think, a month. I have been telling you, and somehow it draw this way. It is not really done well. It's a very simple thing, but somehow I don't know. So what is so here, let me see. It's a TensorFlow. Okay, all right, so let me try to, okay. Can you stop sharing? Okay, thanks. Let me try again. So what I try to say is this. So main, there's a main, Raspberry Pi is the main. And then what do you have? You have a
We have just a camera connected to it. So
camera directly connect to this, right?
yes.
Okay, the camera.
So it has already the Wi-Fi inside. Also,
Okay,
it has,
camera is
yeah,
connected to the board using just a connector, right? The
connector. Yeah.
USB, whatever, right?
Yeah.
Okay. And what else connect? So there is a, do you use Bluetooth?
No.
No. So there's only Wi-Fi, right? There's a Wi-Fi.
Wi-Fi module. Yes.
Yeah. And so you have a ECB board, right?
PCB. Yeah.
PCB.
Yes.
Yeah, this is the IoT controller PCB.
There's a PCB controller.
And PCB also has Wi-Fi inside, built in.
PCB has Wi-Fi
ESP32.
too?
ESP32
ESP32.
exactly
It's
to
a
the point.
PCB, then it's a what do you mean? What do you mean call? It's not PCB. The PCB is the, just the PCB, right? Some hardware assembled in the PCB.
Right, which holds
correct?
devices. Yes.
So how this this Raspberry Pi connected to the ECP?
Professor,
It-
PCB.
It's connected to the ESP32 via Wi-Fi.
We have Wi-Fi.
Wi-Fi again, right?
Yes.
Mhm.
Yes.
Okay, so there is ECP, I think.
ESP.
The
He's talking
professor.
about ESP or ESP home?
Yeah, ESP.
So ESP, yeah. S.
Okay. ESP.
Okay.
And you have a PCB too, right?
Yes.
Yes.
Right. The PCB board.
So PCB board, what does it connect to again?
It has the ESP32 on it. It has the relays.
There's
I
a
believe
Wi-Fi
that's it.
too
Right?
here. There's Wi-Fi here too, right?
Yes.
Yes.
Okay. And so you might, just as an example,
Mm-hmm.
and the ESP connect to what? What is a PCB? PCB is connecting to what?
The
PCB.
4 relays and the ESP32 are on the PCB board.
So PCB board include ESP?
Yes.
Yes.
I see. So this is a PCB, and inside is
ESP inside.
Yes.
Yeah.
Yes. Teacher.
Professor, is it okay if I show you the flow chart and from top to bottom, so you
Yeah.
could
Of the
you asked
PCB,
me
exactly.
last class, so I could go
Okay,
over
so-
it, and then you could
Yeah,
you could write it down, and you could just make a suggestion and draw it.
Well, I just, because I already studied, so let's not take that much time. So here, what I'm trying to say is that the Wi-Fi module is here, Wi-Fi module, right? So Wi-Fi module. So whatever another Wi-Fi, what else do you have Wi-Fi connected?
Hassan is the home assistant server, right? Can you talk about that a little bit?
So in this the Wi-Fi connection, we also we can also do the home assistant server in Raspberry Pi.
For example, like this.
For
And, so this is a PCB,
mhm.
and inside you have a
Inside we have a
ESP,
E32. Yes.
ESP32.
Okay.
And so the PCB connects,
For relays.
so relay.
Yes.
What else?
The
And then
sensors. There's,
it also has sensors.
sensors.
3 sensors.
And
Sensor one or sensor. So what is a sensor? Is the gas sensor?
so gas sensor,
yeah,
MQ2,
we would get-
and then
What?
MQ2 gas sensor. There's a light sensor too.
MQ2?
Yeah, that's
No,
for gas.
okay. Yeah,
And-
so we use gas sensor with
Just a gas
temperatures.
sensor?
and
Yeah, gas sensor.
You have only
temp-
one sensor?
No, professor. Okay,
What
so we have a
else?
gas sensor, we have a
light
temperature
sensor,
sensor,
and temperature sensor.
Okay, gas and temperature
and we have a
sensor
Light.
and
light
light sensor.
intensity. Yeah.
so these sensors are connected here.
Yes.
So
No, this one. Okay.
so PCB is actually has except this connectors, right? It has just ESP inside.
Yes.
So
professor.
Yes.
So how the ESP is put it into PCB? You just buy the board, right? ESP board. Are you buying the board or chip?
We bought the chip, and we
You
have
buy
to,
the
yeah.
ESP chip.
Yes.
How many pins are there?
How many
32.
pins? 32.
So it's like it's like this type of chip.
Mm-hmm.
Yes.
Okay. And what is Wi-Fi then? You're gonna buy the Wi-Fi chip as well?
No, Wi-Fi
It
chip
has
is built in there.
built-in inside.
So it's not chip, it's already board, right? So is it board or is it board
Is
module
it board?
type, or
Yes.
really you have a chip?
It both module type. Yeah.
It's a module, right? It's a
It's
module.
module.
Not,
It's
not
module.
chip.
Actually,
Not chip,
yeah,
yeah.
it's a module. Yes.
It's the module. It's not chip.
Yeah, so that's what so the PCB is actually having, actually it's PCB actually has a, most of it is actually ESP, and this connected pins are actually coming from the ESP, correct?
Yes.
Correct.
It's not, yeah, it's just connector. It's just you connecting this. And Wi-Fi here. So basically you have a 3 Wi-Fi. Of course, MQTT, I know there's a small protocol that, the transmitting through Wi-Fi or Bluetooth. So,
Mm-hmm.
but that is, you may just say here, maybe, MQTT channel,
Okay,
but this is the Wi-Fi, you know,
got it.
this is the Wi-Fi. And so what else? What else do you have? Okay, video camera here. And so what is this? Like
We're
open
using TensorFlow for the human
In the
presence detection,
so
and we have a
yeah.
TensorFlow.
database.
So inside here you can say is OpenCV and TensorFlow.
In
It's
the
like
Raspberry
block
Pi, yes,
functions, right?
correct.
Mhm.
And what else do you have?
We have the Home Assistant server,
What?
the Home
Assistant. So
Assistant server.
It's on the
where
right
does
side.
it
He
reside?
already made that.
Yeah, so where does it reside? So here, right? Is it just what is this? It's a PCB board, again module. What's
Uh,
this?
no, this is the home assistant thing is the open software. You
Is
can,
a software?
it's a software, yeah.
So software is residing in the Raspberry Pi, correct?
Yeah, you can put it also this
So
in Raspberry Pi,
that's what
yeah.
I'm saying. So this is not really, separate physical entity, right?
Yes. And the thing is
So
right now,
actually
Professor,
then there is only two, just Wi-Fi. There are two Wi-Fi module, right?
yes, Professor. So the one thing is here, like we didn't tested anything yet right now because the OpenCV and TensorFlow is this is the large number of the file, and also top of that, if we put in Home Assistant in this in Raspberry Pi, we're afraid it's gonna be keep like slow or something like that. I mean, it's going to I think it's going to give like slow signal, but we don't test anything yet, so we cannot assume that. What do you think?
I don't see that. What did you say again?
So if we upload it here in Raspberry Pi, because our Raspberry Pi is 5.4, so it has like 4 GB. So OpenCV and TensorFlow has I mean, this is the big library, and it has uh, and also in top of that, if we upload also Home Assistant in Raspberry Pi, so we're afraid that it's not going to be give our slow signal, take like more space or memory.
Yeah, but I don't know. So
Because
what else?
we didn't
But your
test
control
anything.
at the moment, your control is very simple controls, right? What control do you have? What kind of controls that you have in mind?
I think the applications themselves will be too much memory for the Raspberry Pi, is what he's saying. If we were to upload all of that, and then we would be adding a computer component, maybe on like a personal computer, where we're able to have those things installed and can run it. And it's really just the Wi-Fi connection that accesses it through the MQTT protocol.
Well, MQTT protocol is very simple. I mean, that is designed to be used in the very tiny IoT devices.
No, but the memory aspect that he's talking about, I think he's saying having the Home Assistant server and then having some other applications like TensorFlow and then OpenCV on the Raspberry Pi itself would be too much memory for our Raspberry Pi.
But I think you already, so, you guys said that, research. So
Yeah.
didn't you look into, how the Raspberry Pi, how much the memory space is needed for, OpenCV together with the TensorFlow? You should have already known. It's not just.
No, but Professor, that is what he's saying. He's saying all three of these applications.
Yeah.
Well, I mean, not around that. Like all three of these applications, like it wouldn't have an ideal scenario for the Raspberry Pi. Even if it does fit it, then maybe the processes are slower, and then that's not ideal to the consumer. So we're having that instead of uploading everything to the Raspberry Pi and having a slower process, or maybe everything doesn't even fit, we want to incorporate some stuff into a personal computer, because Home Assistant is one of the larger files. That's the one that we chose to not have in the Raspberry Pi.
Yeah, then so later on, so at least you wouldn't use the PC, your notebook for the home controller. It has to be on small devices.
But the Home Assistant is like established through a connection. It wouldn't necessarily need to be there physically. I don't believe so. Am I right or wrong, Hassan, about that?
Well, yeah, we don't need to physically attach anything for the Home Assistant. This is a software we can connect from our laptop to by Wi-Fi.
Right. So there's no physical connection needed there, and it wouldn't be. So it would be able to stand alone without having our personal computer there at the time. It's just something that's established beforehand on a software. Our project is able to access that software and it returns data back. That's all that would be happening there.
Yeah, our PC doesn't have to be like involved. Just we have to load it up once and that's it. And once we control the devices, we don't need to open our laptop and to control these.
Yeah,
now.
so
That's
yeah,
what we mean.
So of course, when you develop, so I thought that you're going to use that at the final, the let's say product and the software is implemented on your notebook, and it could be as a controller it could work. But if you are saying that there's just development, of course development can be done on your notebook, and the image can be uploaded to the Raspberry Pi later on. I mean, yeah, that's the people do. So you design everything and test in the Linux. I think you have to and run the Linux on your notebook, and then all the same environment later on, and then you just export that into this Raspberry Pi. Is it what you're saying, right?
Yeah, you can do that, but if we do like we need to test it first to make this assumption, because we haven't tested anything yet. So when you just test it first, and then we're having a problem, that kind of things, and then we can tell you like, okay, professor, we have a difficulty to do this thing.
No, so professor, like what we're saying is, our first intent is to try on the Raspberry Pi, but our backup plan and what is most likely going to happen is we're going to have to use our personal notebook as where we keep Home Assistant, so it doesn't overburden the Raspberry Pi. So like our first priority is to try and use the Raspberry Pi, but through research we're saying that it will be a burden on the Raspberry Pi, and that's why we have the secondary option of using a personal laptop or computer for that need.
Well, so if really, the either, I think in my mind, that either by better version of the Raspberry Pi, that's one, and number two, maybe you might use I think ESP32, you also have a processor there, right?
Yes.
Yeah, absolutely, there is, and there's actually like a lot of different ways to combat the logic portion of it. It could be in the Raspberry Pi, it could be in the ESP32, it could be in Home Assistant. There are different options that we have there.
Home Assistant is a software, right?
Yes.
This is software. Yeah, this is the open source software.
Yeah.
So, I mean, to your question, it's something we have to see in practice to know where we can actually upload all the software, where we can actually go about it. But we do have backups in place for that, is what we're saying.
I think you gotta implement things over this embedded system, not using in the final stage. I mean, during the process development, of course, you can use your notebook, but the final at the end of the day, you have to implement everything on this Pi, or sharing the processor of.
But with the Home Assistant, I think there's a misunderstanding. So it is a software that doesn't need to be uploaded. I don't believe so. It just needs to be accessed, and it would be accessed through Wi-Fi.
Yeah, So it has to be, it's a software, right? It's a
Yes.
software. So
Mhm.
you can
Yes.
access the, so for example, so that's one of the thing I guess you
No,
need to
Wasim,
clarify. So
Professor,
yeah,
excuse me. So because for that, I mean, the Home Assistant also have like IP address. So you need to like download Home Assistant in Raspberry Pi in order to run this Home Assistant in Raspberry Pi monitor.
yeah. So what I'm saying is that I don't know how large is the Home Assistant software.
Yeah. So
So I thought that you guys are just designing the whatever needed is you may not need to use the Home Assistant, right?
because the Home Assistant is easy to control. I mean, easy to the Home Assistant we especially use for our like the PCB board because the Home Assistant also have a like ESP32 the add-on software there, so it can gives you more generic idea to home automation system.
So basically,
So
you're downloading Home Assistant and just to control a couple of things.
no, but it also provides a user customization, so they're able to do more than just maybe what we designed it for. So it's able to incorporate a lot of different things. So it gives the user flexibility, which is what we would like to
Yeah,
give.
it's also you're talking about also like AI there. It's also have some AI there because it's also give you like the customer habits. Like for
So
example, like yeah.
okay, so it can be can it be uploaded later on after you're testing it? Can it be
Yeah.
uploaded to
Yeah,
the
yeah.
ESP3, right? And then from there you can assign the IP address and then you can access from outside. So okay, before this, I think it is not clear that what's going to be a final product look like.
Yeah, the scenario.
So you have to
Um,
explain that to me first. It's not clear.
so which part is the Home Assistant part not clear?
No, whole thing, whole final project, product, right? After the year.
Okay,
So what is it?
so
What is it looking like?
sure. So I can try to explain that. So our first and main priority is the Home Assistant controller, and we're also recently
No,
incorporating
I'm
some.
talking about the final product deliverable. What is the
Okay,
final
yeah,
deliverable?
yes. So the deliverable is going to be it's going to be a PC, like physically, it's going to be a PCB board with ESP32 connected to it that has Wi-Fi connection and a Raspberry Pi. What it's able to do is it's able to use AI to either control things around the house or to give notifications to a person to their phone. It's able to interact in a smart environment in that regard. It creates that kind of ecosystem. So that deliverable is a physical object that holds all these things, that connects to your home devices, that has sensors, that relays information back and forth. So that is our physical deliverable.
So this is a deliverable. This whole thing.
Yes.
Basically,
And
yes.
you have a display here.
So our
Yes, we have display
display,
for the
yes,
Raspberry Pi.
like
Yes.
Okay.
on our, it could be on the
So
phone, yes.
and this is a Wi-Fi. So you have a Wi-Fi. So for example, this device is actually attached to the wall, as you may guess, right? Attached to the wall.
Yes.
Right.
It can be accessed from the cell phone. I mean, cell phone is just
Yes,
sitting
that's
here.
true. Yeah.
Cell phones and others. So you can, and it goes to maybe, I don't know. It's just using the Wi-Fi, it can go, or some of the using the server and go there. So there's a battery operated or the AC operated. So this final thing is, first I think you need to clarify first. Now you said that this is a standalone system that can accept the input from the user, right?
Yes.
So basically, then Home Assistant I don't know whether he can reside here or Home Assistant may be residing here as well.
You can design either or in the PCB or the Raspberry Pi.
So
but we prefer in the
ESP
PCB. Yeah.
ESP the board itself also can implement the Linux, and then Raspberry Pi is also can implement the Linux, and both of them are computer, and you can put the things. Of course, I think memories and that you need to check whether that's enough memory to house Home Assistant here and OpenCV Tensor. Yes, I know OpenCV Tensor because the students are using it. So one Raspberry Pi, not high. What do you mean? High speed? No, but just 1 frame or 2 frames per second. That's doable. For the
Professor, do
person.
you know what Raspberry Pi they use? Like, how much RAM they had used the previous
Yeah,
year students?
I don't know exactly what it is, but I think double check the Raspberry Pi board that you bought is
The one
able
we
to
have is
support
4
this.
gigabytes. So I'm not sure. You said the previous students had no problem with 4 gigabytes, or we're not sure which one.
So haven't you tested it yet?
No, Professor, we're still in the research, so that's the thing. We haven't tested any
What do
of
you mean?
these.
What do you mean research? You just buy the board and it just maybe a couple of hours it runs.
Oh, you mean I should try loading the?
Yeah, OpenCV and Tensor. That's just download it and run it. Camera is just run it and
Yeah,
you
because
see.
we didn't have the camera. So
Yeah,
in
we
order
don't
to
have the
run
camera
this
yet,
thing,
so that's the
we
thing.
need to order the camera. So we were waiting for the camera right now. Yeah, because this thing you just mentioned is like last meeting. So yeah, that's why we're just a little bit behind on this. Well, sorry for that.
Look, other than that, this is look, as I mentioned, it's a whole 1 year just a relay, control the relay, just on and off, and sensor you're reading. I don't know that I don't know whether it's
Okay.
really sophisticated enough. I already told you last time.
No, yeah, Professor. So yeah, go ahead, Rosa.
Yeah,
Yeah.
so Professor, so from last meeting, what we're also incorporating is the camera portion of it, where we're going to try to do something more sophisticated. We're going to try to add some level of AI with presence detection was our goal, which we have in the presentation. So we want to add some level of it, and a scenario that we were thinking of adding is having some type of security to it, where like an example would be like after 12 o'clock, like midnight, if you have like 3 objects or 3 people that are approaching around your door, you get a notification, or you're able to have some level of, it could trip some action in your house. Like maybe it turns on the lights in your home if it senses like 5 different people are in front of your door after 2 a.m., or if they're in your backyard, or if they're like, I don't know, at the side door, something like that. So that's something we wanted to incorporate.
Okay, so okay, the what triggers me to sharing this and then try to draw is I think the way you draw is not really done well. Wi-Fi is everywhere. So something like maybe, and then you're in the legend here dot it's Wi-Fi link or something, right? And so this in the PCB. So this what else do you have? Like a cell phone, or maybe somehow if it's a connect there and display, connect their keyboard, whatever. So somehow I think that drawing is to me was not
Professor, is it okay if I share my
okay. So I think yeah, I will stop here. I think I gave you some idea how to modify your block diagram. Block diagram doesn't. So I like, okay, resources out there, huge resources out there, either presentation or tutorial or how to, draw the block diagrams of this type of thing. I think if you search it, but I don't think that you really search that much. But anyway, so I will let you just go ahead and then present, and then we may come back and discuss, right?
Okay.
Okay.
Sure.
Yeah, go ahead.
So let me.
Yeah, go ahead. Yep.
Let me share my screen so you could see much better than this. Let me share, please. There you go.
Oh, sorry, I was muted. I was asking you.
Here we go. So
Okay, better.
yeah, Professor.
Yeah, much better.
Okay, so here is the top. Let me. Yeah. So here I have the put it here, and this is the IoT PCB controller. The left side.
Hmm.
It's just real down to, and it's very detailed. And I'm going to start from ESP32S is nothing but system on chip, and it has a pin analog ports, and the analog ports is connected to LDR. LDR is a just sensor, light sensor, and then Q2 is a gas sensor, and so when it has like a four general purpose input, and all those inputs are connected to switches, and if something happens, if something is going to go wrong with our system, so we will be able to use manually, meaning like it has four switches, and here's like and also there is a general purpose input and output for later on use. And LED status is, of course, is going to indicate is indicator, LED indicators, and also the pins connected to DHT11, which is humidity and temperature sensor. And also I have also extra expansion. So this pins is like for future use if we need to do so. So coming down to the left, the bottom left, it's like I square C is a bus, and it's like the channel. It connects to display. It's like OLED display. And here we have PCF8574 is just nothing but input output expander, just expansion. So this is expander is connected to, is just giving like input, isolated input, and also on the other side is connected to relay drivers. So let me show you the PCF8574. If I have it here. Here is it. This is PCF8574. This is a module. So let me come back to, let me come back to on the right side.
Is it because of the current and is not good enough to derive the relays, right? So they sort of.
I will come to that.
Okay.
Sure. On the right side, it's the higher level of my PCB board. Whatever you see here, it's on the PCB board. Before you ask like, oh, the ESP32, it's connected. It's not really connected. It's on the board.
Yeah.
Everything is
on the board, but
board.
still connected.
Yes. It's just,
yeah, bus connected, bus.
Yeah, it's, Yeah. So what happens is like this is a 4x optically isolated relay. It's a 4 single relays. So on our PCB board, on the here 4x galvanic isolated input. So it's just input from it starts from 5.5 volt to 32 volt, and then as I mentioned before, this is just I2C port extender. It's just IC, and of course in the middle is like ESP32S. As you mentioned, it has like a 32 analog pins, So, and also DHT11 and MQ2, LDR, all those 3 sensors we have been using on our project. And also we could use, OLED display and also additional GPIO for if we need it. And why we are using 3.3 volt and 5, because ESP32 requires 3.3 volt and 5 volts for relays and some of our sensors. So, and that's it.
Okay. So this is the PCB.
That's the inside look of the PCB. Yes.
Yeah.
This is a PCB. So
and here, like local controls, it's just the button. So if something is going to go wrong with our system, so it wouldn't control by Wi-Fi or by our phone. So we could just go and just switch on and off on our PCB board. It's just manual.
and also, where's the Wi-Fi component here?
So here, here's the Wi-Fi. So what happened is like the Wi-Fi. So I'm going to mention something here. The signals of the PCB board will get transferred via MQTT on Wi-Fi. And see, like on the top left corner, MQTT on the Wi-Fi.
Okay, but so you said that the right-hand side is the layout on the PCB, correct?
Yeah, this is the right side is more like a better picture.
But as you see here, Wi-Fi, the module is missing.
So the module itself, the ESP32 is built in Wi-Fi and Bluetooth.
SoC itself has a Bluetooth inside?
Yes, ESP32,
Okay.
Yes, it has a
Okay.
Bluetooth and Wi-Fi,
I see.
double core chip.
Yeah.
I
know that's.
Let me show how it looks like. Here we go. Like,
Yeah, can you show me the ESP32?
That's better.
sure. Let me. Where's my? Here we go. So here is the ESP32. So
No, I cannot see it. Oh, okay.
So here's ESP32. This is the microprocessor. This is the chip. This
Okay.
one
Inside.
and and this is the USB connector. And this one is the reset. It has two. It has two. One is boot. Another one is reset. Then it has 15 analog pins. This one itself, and like outside it has 32 pins.
I see. So
Very sophisticated chip.
So this will be sitting on the PCB that you're gonna
Right. Like the expander, the one I showed you.
Yeah. Okay.
Yeah,
so you're saying that Wi-Fi is already inside.
Right.
Yes.
Yeah.
Wi-Fi and Bluetooth.
And then one of the pin. Do you have the pin the configuration?
Yes.
Pin?
You can show him the ESP32 data sheet.
Okay, sure.
Yeah. Okay, I think you might have shown this to me before.
You can see.
So where is the Wi-Fi pin? Because it's hard to see now. Where is the Wi-Fi? I think that there is a data in, data out, or something should be there.
Yeah, like this all pin out. It's like every pin has their own functionality.
Yeah. So I see that the GPIO on the right-hand side is all GPIO, and the left-hand side GPIO.
Professor, it says on the top of the thing here, like Wi-Fi room 32. It's already built inside this chip.
Where does it say it?
It says like a Wi-Fi ESP room 32, if you can see.
I can, but okay. So you're saying that, all right, so now I understand. So yeah, this ESP32, this module already have necessary Wi-Fi as well. Okay. But in the pin, can you blow this up a little, because I can't see it. I can't read anything. Yeah. More. Yeah, so let's see. So ADC, crystal, A to D, and oh, here, I think receiver and transmitter, right? Pin
Right.
17 and 18, I think.
Yeah.
That could be the data through the Wi-Fi. But you said you have this also has a USB port?
Yes, it has a USB port. Yep. The connector.
So where this goes, I think.
It has a port here.
Okay. Okay. All right. Okay. No, I understand. Okay. So now ESP has a very good feature. So actually, this is almost the same as Raspberry Pi, right?
Yes, it's
Yes,
Okay.
we was
absolutely
trying to
right.
explain this from the start. I
This is
think
the first
Yeah,
he was confused.
electronic item.
but somehow that didn't come across. All right.
See,
So
see here, Professor, like I can.
yeah.
maybe
Okay.
Zoom,
All right.
Just give me a minute.
So I think that the most of the control functions and the programs may reside here. And the Raspberry Pi may be handling just OpenCV and the
Yeah,
video
Professor,
kind of
that's
thing.
the
Right.
exactly that's
Yes.
that's the
And
exact point.
communicating these two devices using this Wi-Fi port. I think that should
Yes.
do it. Okay.
Professor, you see like where's the Wi-Fi, right? And here you say like where's the Wi-Fi? Do you see like Wi-Fi is here? Here,
Which
like
one?
this one,
The top of the module,
the top of the module.
those
you
are
see
antenna bands for the Wi-Fi.
on board antenna. You see here,
Okay.
Professor. This is
I
Wi-Fi.
It's like very dark,
Yeah, it's
black
very
and gray.
dark. It's hard to see it.
Yep. And then if you could see it on my module, so you might see it much better maybe.
You should stop sharing your screen, then
No, it's
he's
okay.
able
Yeah,
to see.
now
I
I
think
see.
better.
Don't worry, I see it.
it's
So
here.
yeah, this I clearly see that onboard antenna. Antenna is there.
Yes.
Yeah, fine.
Yeah, here.
Okay.
So yeah, let's get back there.
Okay. So for example, usually the antenna, just one information is because the Wi-Fi we are using is a 2.4 gigahertz, I think, right? It's
Yeah,
a
2.4
Yes,
gigahertz.
yes.
So F lambda C is equal to F lambda, right?
Right.
Yeah. So can you calculate what is a lambda? Anybody? Just quickly. Speed of the light, 3 times 10 to the 8 meter per second. C is F lambda.
Professor,
So
hold up.
F is 2.4 gigahertz. 2.4 times 10 to the 9th.
10 to the 9.
And the lambda, calculate the lambda. I think it should be less than 10 centimeter, I guess. What is the lambda?
Lambda is C over F, you said?
Well, F lambda, C is equal to F lambda.
Yes, Professor, is it 1.25? Yeah.
1.25 centimeter. No?
Yes. Yes.
1.25 centimeter.
Yeah.
Very
This is
small. Very small.
Yeah.
So usually the antenna size is half lambda antenna.
yes.
No, I'm teaching the wireless as well.
Oh, okay. That makes
Yeah. So I just pointed out that so because of the antenna size is becoming, as the high frequency gets higher and higher, and antenna size gets smaller and smaller. So the effective antenna is usually designed as at half lambda. So it's like like around
Uh,
1 centimeter. So
Yeah,
that's
Professor,
how
it's
all
very
the
straightforward. It's a
yeah.
very straightforward device. So the pins here, it's like it has all instructions and data sheets. So what we could do, just we could take it as you see here on the
Yeah.
picture,
Okay.
and
Yep.
all the information from
But
there.
you said that ESP also have already the HS Home Assistant interfaces are available from the open
Right,
source.
right. I already.
So
Mhm.
so it's no big deal, right? You just upload this HS system, then automatically you don't need to worry about all the pins. All the pins may be already handled by the driver. When you download the driver for the ESP for the HS, then it's already mapping these individual pins to the HS system. So I think to me, I think it's not, yeah, it's very convenient, I think. Yep. Okay. And when you are writing the program, then I guess you just identify what is the like a mnemonic pin numbers, and then you just send to that to the pin send or read whatever. I think receive a data and send to the transmit data.
Yes, Professor.
Everything. Yeah. Okay. Anyway. Yeah.
Sure.
Yeah.
Should
Go ahead.
mhm.
Go ahead.
Then Hassan can show his
Yeah. From the
TensorFlow
like
research.
Ibrahim. So I think from the block diagram that you show on the ESP,
Mm-hmm.
the right hand side and left hand side, I think it's maybe only confusing. I think you might want to just combine, I think, instead of two. What is the point of this?
Professor, what happened is like here is the drill down, meaning like it's very detailed one, and on the right side is very it's a good picture.
Yeah, but still, I think
A higher
the
level.
Wi-Fi should be here. There's one big communication part. Without communication,
Okay,
yeah,
I
put
would
it
do
there.
that. Definitely, I would add the Wi-Fi there.
Yeah.
So which one do you prefer to keep? Like,
Well, I think that this one, the left hand side is a good, but this is a because you are not really laying out the PCB design, right?
so what happened is like this is from the top to bottom. So what happened is like I did it last time. So you told me it's like, oh, what is that part? What is this part? Like I'm basically using on the software. It's called like Easy EDA, which is not for regular people. It's just only for the grad school, and it's been using the FPGA. It's not easy, and like designing a circuit is not for undergrad. It's some exception. It's some exception, but yeah.
Okay, good.
Mhm.
You got to do the exceptional work.
I mean, Professor, like as you mentioned, is like we are designing our own PCB board, which is not easy at all. I can tell you that. It dedicates so much time.
Yeah.
And like especially like with Easy EDA, I have to go search every single parts, which is not easy at all.
Okay.
And even like I ask here, so who could design PCB board? No, but could design PCB board in at CCNY.
No, I think you just use the software. I think it's doable. It's not really Herculean job. You should be able to handle it, because you're able to do it, I think.
So yeah, because what happened is they used to teach some designing courses, but no more. I asked them here.
Well, the good part is that there are a whole lot of tutorial out there, I think, right?
So maybe let me show something here. Like if I see here, like yeah, this is Professor.
Yeah.
It's and this is the one part relay. This is the one. It's not easy.
Okay. So is this the software?
This is the software. It's called like Easy EDA.
Okay.
The PCB.
So, yeah. Okay.
Yeah, like you see here, like want to relay and This is the thing.
So once you design that, and it suggests this layout, right?
Right.
Okay.
And
Yeah.
I could do like a 3D part too. In the 3D.
So here you just incorporate this ESP32, right? 32 pins.
ESP32, yep. And I ESP32 and also 4 single relays. The lights. I mean the indicator and also the sensors. I have to put all of them. Yeah, I have to put all of them on this board. Incorporate with this thing.
So once you do it, will you send out to a some company that soldering and all that?
So
what
go ahead.
We're able to do that ourselves too.
Yeah.
We have a solder.
Yep.
Are you able to do that? So, but PCB, who is going to make you the PCB? Our technician?
That's going to be shipped from the PCB board itself.
Yeah.
That's going to be shipped, right, Ibrahim?
So the whole point is just to make your own PCB board.
Yeah.
Yeah, like and then you could
So
send.
where do you want to send it out? Because I think we had some antenna design, and our PC student did it using our department machine.
Oh, that's good. If someone's gonna help me, that would be perfect.
But that is, I don't know whether that is really this sophisticated design can be
So
done.
and then we're gonna be designing our own PCB board, and then we could send it out. So what they do is they print it out and send back to us.
Yeah. So I think okay. Before
and then the soldering part is we have to do it manually. Like I have to do. I'm sitting in the lab, robotic labs now.
Have you tried before?
Yeah.
The soldering?
Yeah, soldering. Yep. I do.
Okay, good then. Yep. Yeah. All right.
Yes.
But I think you may want to find out how much it costs and how long, what is the turnaround time when you send out the design and then receiving the board. So you got to check with the vendors, right?
Sure.
Yeah. Sure. Instead of waiting to the last minute, I think you got to just, find out early on.
Yep.
Yeah. So say, for example, if they claim that, that's, several $100s, then, hey, we gotta think about some alternative design.
I think that's not several $100. I'm sure it's less price, but the point is like, what's worth it? The worth it is our work, our meaning, like it's the design. The only thing is just you send the design to them. What they do, they print. That's all they do.
Hopefully that's. So do you roughly guess what is the the price?
Yeah, it's around. I'm not even sure. Maybe.
I think it was maybe under $50. So I'm not sure exact price yet.
So I think okay. So that's a part of the thing that I think you gotta find out, right?
Yeah, I have to.
Don't wait until the end.
Okay, we will do that.
Okay.
We'll find it out.
Okay, go ahead. So I think if that is the case, detailed one is better for me.
The drill, okay. The drill.
Yeah.
Okay.
Yeah. Detailed, right?
Thank you so much, Professor.
Yeah, and so I think if you are able to do it and maybe group similar things together, all the sensors together, right?
Yeah, then I have to put all the sensors. I have to solder the.
No. What I'm saying is that the drawing itself, this drawing itself, the relays are there. Okay, the expander there. I think this is fine. All right. I think this will work. The left hand side will work.
Yeah, the left. Okay.
Yeah. Okay. Go ahead.
Okay, Hassan, can you show your research for the TensorFlow?
Yeah. So, can you share the screen because I have some.
Wasim, can you share?
Yeah. You have to stop sharing it, right?
Oh, sure. Sorry.
Yeah,
okay.
from
Go,
here.
no, go up.
To
Yeah, this
the
one.
fourth, yeah.
No. So, Professor, so you sent like the email last week, and then we mentioned like we need to see like TensorFlow and OpenCV. So we're just like heavily focused on TensorFlow. I mean, for this week. So, so what is the TensorFlow? So we know that the TensorFlow is an open source software library for machine learning and artificial intelligence. So it can also focus on train and inference of deep neural network. So the implement this software, we can use like C++ because we already have a knowledge of C++ and also we have like the knowledge of Python programming language. Go to the next slide.
By the way, I think it's good to, to be familiar with the Python, right? This time, I think you may want to, write all the things using Python.
Yeah, I mean, yeah, we can do that. We can do that because in Professor VR class,
Yeah.
we took the C++ and Professor VR gave us like 2 projects to transfer this C++ to Python. So we did this. So if we figure out like C++ and we can figure out Python too, no problem.
Okay.
We do have a few options there, Professor Lee. We can incorporate it onto the Raspberry Pi or the ESP32 or the Home Assistant. They all have different various programming languages.
Yeah, because the ESP Home Assistant, you cannot programming with the Python or C++. We can program YAML code. So YAML code is a little bit different than C++ in Python. Yeah, in Home Assistant. So there is so in next slide, so SPD for the smart home. Yeah. So the SPD
What is
stands for like
HPD? What is HPD?
So HPD stands for Human Presence Detection. Is application which is use machine learning in order to detect the person or the presence of human being. And this is done by using a combination of convolution neural network and TensorFlow, which along with Raspberry Pi. Go next slide. And then, so what is because this is the biggest part of the machine learning right now, because we're doing the face recognition and also like the presence detection. So this is the biggest algorithm. How is a convolution neural network is work? So the convolution neural network, CCNs, are a category of neural network that have proven very effective in areas such as image recognition and image classification. And it also have been successfully in identifying human presence, human presence, face, and object. In the next slides, so the whole scheme is like how is convolution neural network is working. So the convolution neural network has 3 types of layer to build architecture apart from the input layer. So it's here like in fun like I use like the cat's face to input image. So this 3 layer is like the number 1 is the convolution layer with the ReLU activation. The second layer is the polling layer, and the third layer is a full connected or a dense layer. And then the convolution neural network architecture for a 2-class classification problem. So here we use 2 classes. One class is for cat, the other class is for dog. Other class is for dog. The word is input image is present to convolution layer. It is to extract information from the information from the input layer. In the next layer is a pooling layer. The pooling layer is reduce the extracted information, and which is also called a downsampling layer. And third layer is the third layer is a flattened layer, which is just a convert matrix into a vector. In the dense layer is usually available at the at the end of the convolution layer. So I will explain each of every layer in upcoming slide. Can you change the slide? So in this convolution layer, the primary purpose of the convolution layer is extracts feature from the input image, and so the convolution layer is extracts inputs from the input image. Then it is produced output by simple convolve the input image with a filter. So here is we use filter. The filter is like 3x3 matrix, and our input is here is like 5x5 matrix. So 5x5 matrix, and the output is also like, because output is also given like 3x3 matrix. So how is this work? Can you go to next slide? So the convolution layer operation, for sake of understanding the convolution layer operation, we have chose like the 5x5 matrix, and input the image and with the filter 3x3 matrix, we impose 3x3 filter in our input image. Like here, like we impose the filter in our 5x5 input image, and like our output is element is one, the row is one and column is one, so is element is 1, 1, 1, 1, 1, and we just did the algorithm is like we multiply the element by element, and we got after that the result is coming 2. And the same way we just shifted like the 1 unit right to our filter, and then this filter is now give element 1 is element is 1, 1,2, and we did same thing, did like the element by element multiplication and get 3. In same way we get 0, and also we get 2, 1, -2, 1, and 0. And then because the thing is, sorry, because our what is it called? Because our computer has like our computer, we know that our computer has we just only have like binary input. If the computer have like the grayscale fixture, so it can give you just only 0 and 1. And if it is like RGB, it can give you like it ratio the size is like 1 to 2. I think, yeah, 1. It looks okay. So RGB, then we have 0 to 255. The image pixel, and yeah. So go to the next slide. So in the next slide, we'll do like ReLU layer. The ReLU stand for the reflect linear units, and it is a type of a activation function. The function is f of x is equal to maximum 0 to x. So here is doing like in this layer, our output is become input right now in ReLU layer. So, and then this layer in output is become is y is 0 here right now. So this is the main thing. So the 0, this layer is protocol is like if is 0 is less than anything, any number is 2 is less than 0, so its number is become 0, and 0 is equal to 0, and 0 is greater than any number is retained the same. So that's why is this only -2 is become 0. So in the next slide, and also like from the graph, we can see like the x-axis. If you put like greater than 0 number is like 2, is give you 2 in for function f of x.
This activating function is very specific for the CNN, but other deep neural network use a different activation function, usually hyperboles and other types, especially 1 over 1 plus 1 plus exponential minus something, so that the neuron taking all the weights. And so this is one specific activation function for the this convolutional neural network. Usually one of the motivation for the CNN is that the artificial intelligence is nothing but they call it feature engineering, feature. So there are so many features, right? So the image, how many pixels you have, right? There's so many pixels, but all this pixels is a candidate for the features. But imagine so many inputs are applied, so it's very, very, very hard to design it. For example, if you design this VLSI, and input is thousands of pins, there is no way of doing that, right? So what they do is that they try to minimize reduce the size of the feature, and that's why they are using this particular image filter.
Yes.
But CNN is working in general, but mostly is the designed for the image processing.
Image processing, yeah.
Not others. So for example, our PhD guy is using this deep neural network implementation using the stochastic computing, where the input is like a 16. So they try to detect the intrusion, right? Cyber attack, DOS attack and other attacks, right? In that case, number of features is maximum 40, but by designing different ways, you can reduce down to like 15 or 16 features. In that case, you can just put it there, but this image is totally different animal, right? So the CNN is specifically designed for the CNN. I'm just saying you that, yeah, this is not a representative activation function. There are many other, especially the softmax is more, I think, this time.
Yes, softmax. I'm going to
sigmoid and softmax. I think at the output layer is common to use a softmax. So anyway, so it's I think you have a good time to read all this, right? And so it's good to share with your fellow so that just understand together. Good. Yeah, go ahead.
Okay, go to the next slide. Awesome. So the pooling layer. So the pooling layer would reduce the number of the parameters when the input are too large, and what you're talking about right now. So the pooling also call down sampling. It also call down sampling, which reduce the dimension of each map, but retain the important information. So there are 3 types of pooling. Pooling mainly the max pooling, average pooling, and sum pooling. So in deep learning and machine learning, where max pooling are predominantly used for convolution neural network. Say for example, in the previous example, we have a 3x3 matrix, which is getting from the output from our ReLU layer. So here in this layer, we also have a filter. We also have a filter, 2x2 filter. We use 2x2 filter here to simplify this simplify this matrix. So we did impose this 2x2 matrix in here, and we just make it we just combine the numbers. It's like, okay, it's 2, 3, 0, 2. Which one is the bigger number here? So it's 3 is the bigger number. So we choose 3, and then the same. And then we shifted our filter is 1 to right, and then also we combine here which number is bigger, and we choose 3 from there. The same way is also 0, 2, and 0, 1. Is the bigger number is 2, and here also the bigger number is 2. So This is where we're pulling we're like yeah, we're choose our like the maximum value to the element we have choose the maximum value. In the next slide, Wasim, can you go to the next slide? So is a pattern layer in the feature of matrix will be convert in this layer. The feature matrix will be converted as a vector. So is 2 by 2 input what we get from like the pooling layer is become now is input in flattened layer. In flattened layer, the input is become like a now is matrix to become a vector in output in flattened layer. So and fully connected layer with ReLU. So this is the another layer, and this layer we have like the 4 neural networks. So one is like A11, A12, A13, and A14. That is why that is why we chose here like we chose a number from 0 to 1. So because we're trying to keep things simple. So and then the x is what we're going for. The x is like our like the flattened output what we get from this this x value. And then we did like simply like the matrix simplification, and we get the ReLU value is 8, 7.1, 7.4, and 7. Because is the ReLU value is doing same things here too. Same things here too, because there is no number is less than 0. So is keep the same output. Is keep the same number is for the output. and the last slide, the next slide. So next slide. So the professor user mentioned is like softmax activation. So is the fully connected layer and softmax activation. In this layer has like only two neural it's 2 neural layer. So in the both neural receive bias as well as input. Each neural has its own bias and also has 4 different input. For this previous the fully connected layer A1 after multiplying with the corresponding weight. So in this order, to find out layer like the equation is like the output is O is equal to W2A1 plus the bias is B2. Okay, so in here W2 is a weight matrix initialized for the output layer. The A1 is output for a previously fully connected layer, and B is a bias output layer. For here, we just the same thing we did. We just randomly chose number from 0 to 1, and also this is our A1 what we get from the previous layer. And then also B1 bias, we just put like randomly like 0.1, 0.1. So we obtain this this result for O1 and O2. For this, then the output layer is connected with. So this output layer is connected with softmax connective activation function. The supplement activation function work in this fashion. That is which class has highest probability that will choose as the final result. So especially we're flagging this number here, and we get this highest value 0.95 and the lowest value 0.4. So what does this mean? The 0.9. So the highest value we chose for this softmax activation. Can you go to next slide? Oh, what is the other one? Okay.
No, which one? That's the last slide.
Okay, so I'll just go to the first slide, all the way. No, it's like number
This one?
8. Yeah. So okay, so in this case, we choose because the highest number is we get a like layer of first layer is that the class 1. So that is why this shows like the cats is the facial here because of neural network. Yeah, the final output is this problem is class 1 and the class 1 is cat. So this fashion is convolution neural network is work. So basically the neural network is combined in your random number, and then the fictional for this, and the highest number is going to choose for this the face recognition thing.
Okay, it's a good summary. Good. All right.
And then one of the
Now is the
last
time to
components.
just put it into camera and try.
Yeah,
It should
yeah,
work.
we're going
It
to
should
do this,
work.
Professor. Yeah.
Yeah, it wouldn't take that much time. Just yeah.
So one of the last components we wanted to talk about, the mobile software part of it, where we have the Android phone. So this is kind of like a basis that I look by on current home automations or UIs that are user friendly. And this is something that I'm like trying to make the user interface for. So I'm trying to have like color coordination, and I'm trying to have like the text bigger. So it's easy to see and it's easy to use for elderly or for anyone trying to use it. But so yeah, this is kind of my basis, and this is what I have. This is actually through the MIT app inventor.
So the one suggestion is that color, because you use the color, that's very good. And color red is really emergency, right?
Yeah, so I mean, this one is for heat, which is kind of correlated. So I mean, it's not the same, but yeah.
Yeah. But I think so try to select a good color that might link to the real what's happening out there.
Okay. Yeah, definitely.
Yeah.
I
So
think that's
again,
that's
what is the platform that you are using? I mean, the software.
It's called MIT App Inventor.
MIT app. Okay. All right. Is it graphical interface or just a writing program?
So there's both aspects of it. There's the graphical side where I'm able to like create these buttons, so I don't have to write like hard code to create buttons. But then the logic portion of it that like does have to be created through writing some type of logic. So like I mean, like this doesn't do anything. I have to connect it. That's one aspect of it, and then the other aspect I have to like for instance the logic portion of it. So if like 3 people are in a room together, turn the lights on or something like that. So that part still has to be written.
Yep. Okay. All right. So this is the initial design.
Yes.
Okay.
This is the user interface initial design. Yes. This is actually what it looks like as of right now.
Okay.
So I think besides that, we can go over the meeting summary from last week and like if we missed anything or if there's anything else that additional that needs to be concerned. Let me pull that up. Not this one. This one.
Yeah. Can you blow it up? Yeah. Okay. So let's. All right. So let's go over one by one and see if you. Okay. That's the information. Why are we using both? Okay. So. Yeah. Okay. So now I think it's clear.
Right.
Yeah. So the PCB is not separate from the PC. The PCB itself contain the. So I think you gotta somewhere you note of it.
That the ESP32 is inside the PCB board.
Yeah, it's inside the PCB. It's sitting inside the PCB board, and it also embeds. You may just when you present it, I think next time is so that the block diagram can represent that, right? The PCB and inside the ESP chip, and inside the ESP chip, you're sitting Wi-Fi, right?
Okay.
Yeah.
Yes.
Okay, so now TensorFlow with the Raspberry Pi. So yeah, I think now you are ready to run this show. So I think it's good. But now how to use it? Yeah, the immediate thing, as you said, is just whether there's somebody. But I think maybe solidify the scenario a little bit more, right? As you move on. the usage of the AI.
So Professor Lee, regarding that, and like after giving a more thorough explanation,
Yeah.
is there
Okay,
is
so
there certain
yeah,
so
develop some the scenario that is related to the presence human presence detection or something, right? Yeah.
so is that sufficient for you? Is that something that you're looking for?
I think that's what you mentioned, right? So what are you going to do with this the machine learning thing?
Uh,
So what is the application scenario that you're going to use this AI for?
Yeah, I think one of the major things is the presence detection, and that's like just one example scenario that we gave, but I'm sure it can be optimized or there's better scenarios, or
Yeah,
even that
so
one
I
is
think
not.
what I'm now commenting is that try to develop good scenario
Okay.
Okay,
utilizing this.
Professor. We will
Yeah.
do
Yeah.
that.
And remember that the last time I told you that all your guys, one of the team was doing like at the presence in when they are approaching the door and see this, and if nobody there, then it connects to the guy owner who is working and do the cell phone so that he can open up the doors and something like that. That's also right, remote access type of thing. So you can think
Um,
about some good scenario.
so
So
what do you
for
mean by remote access? Like they're able to open from their phone?
Yeah, so if somebody, let's say there's some fire smoke coming out, and then it has an alarm, and somebody next door wants to open up and then try to put it off,
Oh, you
and
mean like it's a safety scenario?
yeah, safety scenario, yeah.
Safety
So
scenario, like if
yeah.
in emergency scenario, they should turn off this thing and
Right, turn
open the
off,
door.
but at the same time, if it continues, then even neighbor can go in and try to put off, right?
Oh,
I
okay.
don't know whether that is a the privacy issue or not, all that. That is a possibility, but so you just approach the door. You,
Mm-hmm.
just one scenario. Somebody approach the door,
Mm-hmm.
and this your database. By the way, so all four guys will train the OpenCV first, right? You will train so that your faces will be recognized. Different, by the way, the training it should be done in different light conditions, different angle of your face, right? For
yes,
example,
please.
and all these things. So your family members will have even like a half of your, even with a mask, they should be able to recognize who you are. But for the other guys who are just approaching the door and not found in the database, right? And then it alarms, but it alarms at the same time. It may be alarm to. I'm just talking about one possible,
Like scenario, right?
scenario,
Yeah.
right? So then, let's say you are the homeowner, right? And
Mm-hmm.
then you went to work,
Right.
and somebody just at the door and ring the bell, and somehow after some recognition software couldn't identify any similarity with the stored database, and then it will alert the homeowner using the cell phone, right? And then the cell phone may turn on the video camera, already capture the guy, the stranger, and then that you at the company you can see this face, see whether that you really know this guy. Then you might as well just open the door for him, right? Something like it.
So
Mm-hmm.
But I
Professor,
think
like
just as I mentioned, just develop one item is that develop some yeah, as you said, the security scenario using this machine learning. Okay.
I think like based off the research we did, we were trying to move more into presence detection as opposed to face recognition. Are you
Okay.
saying you want to necessarily see face recognition?
Why not? Because OpenCV does it. It's simply
Because
you train it.
because I believe from our research, it's like a more like to upload the images onto Raspberry Pi would take like a long time from what it shows. And not just that, then you have to take like hundreds of photos as well that you have to upload onto there. So that process itself would not be smooth.
Maybe not. I mean, in this demonstration, right? Maybe it's just a photo view guide. So
Right.
it may not take that much of a space.
Okay.
Yeah.
Yeah, we
But
can
anyways,
definitely get back.
yeah. The object detection, yes, that's certainly one of them. Yeah. If it's a simply object detection, maybe camera is too expensive. Object detection can be done using the ultrasound sensor.
Professor, the camera is
Got it.
not that expensive, I think.
Yeah. So what I'm saying, I mean, that's what, because you said that presence detection can be done by the ultrasound sensor. There's a small, like a two transmitter receiver thing.
Yes, Professor, is that the
yeah.
RF sound? Yeah.
Yeah, ultrasound. So that really detects very nicely. I mean, yours and my car have this ultrasound sensors, several sensors that detects the because bounce back, right? Bounce back. The LiDAR, of course, is another thing, but the ultrasound sensors also does the job. Anyway, but so yeah, the camera itself is not expensive. All right, so just think about it, and yeah, as far as this decent one, that's fine.
And Professor,
Okay,
we will contact you regarding the block diagram overall. I will try to contact you and email you and show like if it's up to your
okay.
up to your
So
car.
let's okay. So let's everything
I'll
done.
keep in touch with the email. Okay, yeah.
Well, just to comment on this one, the tax exemption. Professor Bourne said there is no tax exemption that we're getting. We're just supposed to
just pay.
Show our
Okay.
I think besides the design function, so after seeing Ibrahim's,
you showed me that
we showed you the function diagram for PCB.
Yeah, functions of the PCB. Yeah.
Yeah.
So would you say that's good?
You put like a good title there. Yeah, I think so. Let's see what kind of current source on the PCB. So what? Yeah, did you figure this out? The current rating.
The current source on PSP.
Yeah.
I believe we did.
I think Ibrahim did mention like the galvanic it takes 3.3 volts and 5 volts. I think that's what he was talking about.
What is the ampere? What is the ampere?
What is the current? It's 5 volts. Ibrahim, do you know the answer to that?
Just find more.
Yeah, we will clarify this.
Okay. And what is this thing? The kind of current source? Okay, what do you need? Okay, so now you have 2 volt. Okay, so 2 volt should be enough, I guess, right? And a lot of confusion around the circuit. Yeah, I think that's where the function that will perform. Okay.
Yeah, we cleared that up. Yeah.
Think of the scenario that our project will be targeting. Yeah, turning off the light is not enough. Think about the facial. Yeah, I think good. I think so. But except that just the functional diagram, try to redraw as you said. Just send it to me, right?
I will send it. I'll keep in touch with you.
You don't need to wait the next 2 weeks.
Yeah. So I think.
And then also, like I said, I like to see these individual components working by the end of the semester, right?
By the end of this semester?
Yeah. Individual components. So you should be really working, diligently to make the functional components so that you're ready for the next semester to be integrated and integrated. That's a lot of difficulties integrated and the signal communicating each other and all that. But the individual components should be checked. What the function is really, correct.
Yes, Professor. So Hamza, so can you order the camera because
yes, I will do that. Okay.
Yeah.
If you need it, I have several things, several cameras at school
Oh, really?
from the former, but I gotta go to school. So
Professor,
if you have it, it's just borrow and first and try to do it.
Professor, are you in the school?
No, I'm not.
So are you coming to school?
Maybe, yeah. I'm not sure what day of the next week, but I may go. But
Sure, then I'm gonna email you. Okay.
Professor, is there a set goal for next semester? Are we going to be meeting you? Because there's no time slot for senior design. Is it going to be just like this?
next semester, 70%. I think this is a hybrid, right? Hybrid, or I think it's a hybrid.
I think it's
So
hybrid, yeah.
hybrid, at least once, we gotta meet. So I think maybe the semester and the presentation we may do it at school, at least once.
Okay.
And the next semester, I don't know. The basic guideline is to have like a 70% of the class in person. That's, I think, what the hybrid is. I think this senior design is a hybrid. So
Yes, this is hybrid. Yep.
yeah. So I think maybe I would say maybe a couple of times next semester. Maybe this semester, maybe once toward the end.
For the presentation?
Yeah, for the presentation.
That's the same presentation with Mr. Boren, right?
No, it's not same. Well, we can ask Borin to join our presentation.
No, I think that's two separate ones then, because he also mentioned one. I think that's in front of our class. And then, so you're talking about one separate one for you?
Yeah, this is just ourselves.
Oh, this is
Okay.
our with professor. That's
Yeah,
it.
yeah.
Not with Boren. Yeah.
Yeah. So the Mr. Borin's class will be in school.
They're not for this semester, but he's asking us to come in for smaller things. Like we have to come in for a safety meeting.
We're just watching some safety videos.
Yeah.
Professor
And then
also
for the
requested us to
presentation.
show up to and recite the oath for IEEE rules.
What do you mean?
He asked
Like
us to.
ethics and moral, something like that.
He said, "Oh, you have to recite the IEEE rules in front of me in
Ethics,
person."
yeah, ethics and
So that's why he's asking everybody to show up to the to his
Okay.
office.
That's interesting. Yeah, good.
And yeah, exactly. Yeah.
But I think these days the school is wide open actually. So you just go in.
Yeah, for like studying, yeah, we're able to go for that reason.
But still, it's not safe, because what happened is, like, my sister lives in Europe, so her daughter went to kindergarten, and she got COVID from kindergarten and transferred to the whole family. And the
Wow.
whole family, the whole family is
Wow.
in the bad.
Yeah, I know that even New York City, right? In all the public school, except college, right? So it's a mandatory.
The vaccine
So
is mandatory.
everybody. So now the COVID case actually increasing, as you just
increasing,
mentioned, at the school.
So my sister, she got 2 shots, the vaccine shot. So still she is in a bad condition, and she's not even talking. She hardly taking breath. I was like, what's yeah.
Wow.
Yeah.
Hopefully she feels better, man.
Yeah.
Yeah, we hope for a speedy recovery. Yeah.
Yeah. All right. Hopefully that recover, soon.
Yes.
Yeah. So I think because I think we gotta meet at least once. Just so I'm thinking that maybe the last maybe first week or second week of December, yes, we just get together and you flex your muscle, right?
Okay, Professor.
Okay.
Professor, just
All right.
one thing I just wanted to show this week's meetings notes, because I don't I just want to make sure we're prepared for next time, because we didn't have too much that was said about it. So I mean, I have the diagram that we're gonna
Okay.
do. I mean, just
Okay.
like for an example. So I just want to go over.
So just going around, you may have a better idea, so
Right.
take a look at those, right? Yeah. Okay.
Yeah, absolutely. But I just wanted to review the points because so we have better idea what to
Okay.
do for next time.
Can you blow up? It's hard to see it. Okay, good. Yeah, block diagram, Wi-Fi is inside. Okay. And ACPs I can both use to for yep. The Wi-Fi block diagram inside. Yep. Find out cost of sensing. Yeah. Okay, so that's good point. Yeah, put all sensors right. So all the physical components should be there, and then you gotta name it, right? So it's like as you said, temperature sensor, gas sensors. So like a sensor group, and then you name the sensor groups, right? And so, okay, Python for writing. Yeah, I thought the Python is everybody's using Python these days, and a lot of open sources are there. So I thought, okay, but you say C++ there? I don't know, the GitHub, especially I think the AI thing is the Python is the language.
Yes, Professor. The AI thing is Python is more usual
Yeah,
language.
the more libraries and
More libraries.
yeah, because my PhD students are using Python of the machine learning thing. So
yeah.
But anyway, okay, the PCB board has a embedded inside. Yeah. So I think it's you already have it somewhere, I guess. But anyways, it's yeah.
Reiteration, so we don't
bullet.
miss
So
that.
you just rearrange, right? Yeah. Because I must have said several times already. So
yeah.
develop scenario human. Yep, that's good. Example, there is a smoke. Okay, that's one example. Object detection. So you basically, I think I will say, yeah, that's the term. Develop scenario of like a safety safety scenario, and under it you can have the example. Yeah, this detection. Well, so what I was saying is that since the video camera is already much more capable than the ultrasound, right? So what I'm saying is that if you're using just camera, although it has a even face recognition capability, but using that only the presence of the object maybe is too overkill, right? That's what I was saying. Do you understand what I'm saying?
Yeah, absolutely.
Yeah. Okay. Yeah. So I'm not suggesting to use the ultrasound sensor.
Oh, it's like you just threw in.
No, yeah, absolutely.
Depending,
I was just writing that as a note.
Yeah, depending on your real final application. If you only want to detect it, not recognize it, then you can use the ultrasound. That's what I was saying. But I think.
Yeah, absolutely.
Yeah.
So I mean, in terms of to do for next week, it's mainly just the block diagram then, right?
Yeah.
And then continued research.
Yeah. So okay. So the final one, it's not try the final the last bullet. Last bullet item. Yeah. So at the end, I already told you several times. I think it's not. It shouldn't be a news to you that the goal of this semester is to build the individual functional component, right?
Yep.
And then so that you are ready to go to the next semester to integrate and testing and improvement of the performance and so on, right? That's the final goal. Okay.
Next semester, testing
Integration, testing, performance improvement, and demo system. Nice demo. Yeah. Okay. All right. So I think instead of waiting, so I think because we meet this week, so I think we may meet next 2 weeks, 2 weeks after now. But don't wait. Some of the things you have and any question, just send an email, right?
Yes.
You can talk.
Sure, Professor.
Professor,
Okay.
we're gonna try to show you the functional diagram before we meet next time.
Yeah,
Yeah, I
by
think that,
by
that's
email
good.
we will show you the.
Yeah,
if
email
it's-
fine.
Yeah. Okay.
You know, I will look at it and
Hmm.
because I mentioned several times the functional diagram, so now I think you get it. Okay. It's also presentation. Instead of plain thing, it's just to make it, you know, nicer. Yeah,
Is there
and Google
anything
it.
specifically?
Google it. I mean, you if you Google it, then there's a lot of, you know, embedded system design functional block diagram. You type it, see if what turned up, and colorful and nice thing, right? Okay. Any
Yeah.
question?
No questions. So
Okay.
far.
All right then. Okay. See you in 2 weeks.
All right.
Okay,
Thank you, Professor.
Okay
Thank you
then.
for your
Thank you,
time.
Okay.
Professor.
Bye.